Hi, I'm James and this is my LetterBot. This video is really just to give you an overview of the hardware, a quick demo and talk you through all the bits and how they work and how it all bolts together. So the LetterBot is actually based upon a Spark core, which is this sort of small board in the middle here, and what you should hopefully be able to see is that big silver chip right there in the middle. It's actually a bit of shielding over the chip, but that's a Wi-Fi chip, a system on a chip, and what that does is it uses this little antenna here and gives you about the same range as a mobile phone. You can program a Spark core, it's very similar to programming an Arduino. They've done a really great job of building the IDE, so you can use libraries, and a lot of the stuff is ported over from the Arduino environment. If I just quickly take that off the board, I'll show you the underside. It's important to note that the Spark core, whilst you can do Arduino type things on it, it's actually quite a different beast. There we go. So what you can see under there is right there in the middle, that's your main microcontroller, which in this case is an STM32F103, which is a 32-bit ARM Cortex M0, I believe, clocked in at something around 80 something megahertz. So it's really quite a lot more powerful than a standard Arduino. What you can also see just on this side here is there's some additional memory on board, so you can store your program up to about 2 megabytes is addressable with this. So if you're doing something really complicated and big, then you can do that. What the nice thing is about this board, first off, it's absolutely tiny, as you can see. You've got quite a lot of I/O, but there's quite some big benefits that using that STM chip brings. So it's got things like an onboard real-time clock, and the guys at Spark have built the firmware so it automatically pulls the time from a network time protocol server every time it boots, so your RTC is always in sync. And also you can see here that it's got plenty of pins. It all runs at 3 volts, so that's either a blessing or a curse depending on the modules you're using. And it's just it's a pleasure to work with, to be honest. It's programmed via the web-based IDE, and it's flashed over the air. So you see this little RGB LED here. That's sort of there's a layer above the Arduino code that executes all the Wi-Fi instructions and deals with flashing over the air and that sort of stuff. So so yeah, the main brains of the operation really is the Spark core. If I just slot that back in there, what you'll see is the Spark core is actually mounted on the board using a pair of dip sockets, and I did this because I ordered some female header pins, and when they arrived they were this type over here, which is great for standard 3-hole components like this transistor, but with the relatively thick pins on this Spark core, it just wouldn't fit. So luckily it's exactly the same length as these big dip sockets here, and it fits rather perfectly. So we'll just slot that back in. Next thing you can see is that the board is a green coated glass fibre perf board. I really chose this prototyping board specifically because I've used strip board in the past that use that sort of paper type brown board, and it's not very visually appealing, and it doesn't look particularly finished as an end product. So this just looks a bit nicer, and it's significantly more rigid. Moving along to the bottom here, what you've got is four sets of screw terminals. You've got the first pair, which are sort of banked together because they're both going off to the doorbell push button. So there's a pair which are the switch of the doorbell button, and then this pair here is for the LEDs that I've mounted inside the doorbell, because LEDs really. Next along here, what you've got is a pair of screw terminals for the micro switch. There's going to be a micro switch mounted in the letterbox, hence the name LetterBot. so when the postman delivers the mail, that will be triggered and I'll get a different notification via the spark core. Lastly, this pair of pins or screw terminals here is for activating a traditional doorbell. I'll get onto that in a moment, but the pins there are hooked up to this relay, which should get into focus there. So it's just a cheap 5-volt relay. It's triggered by any sort of 5-volt source, and you'll see if I swipe it around here, what you can see there is that I've got a standard diode across the trigger pins, but I've also got this transistor here, and the transistor's there because, as I said earlier, the spark core runs from 3.3 volts, but this relay here actually requires 5 volts in order to fire properly. So I've just got 5 volts across this transistor, and it's activated with a 3-volt digital pin over here on the spark core. The only other items that you can see really are the my sort of really hacky way of doing power rails. So up the top here, what you've got is a row of male header pins. I'll just raise that up to the camera a minute. A set of male header pins, and if you look really closely, if I can get it in focus, just move that slightly away. There you go. You can just about make out there that there's some really small wire looped from one pin to the next, and it's just a little bit of solder holding it on. And what that means is effectively on the back side, every single one of those pins that's through the board gives me 5 volts on the top, and a place to ground any components at the bottom. So that's really sort of handy, because perf board, if you had multiple components soldered to a single pin, it can be a bit of a pain to get a reliable connection in that. So you can see a similar story down here. So it's a much smaller rail. If I focus that, I might be able to get a good view. Okay, it's quite tricky because they're obviously quite small components, but yeah, there's 4 pins there, and they're offering 3 volts, 3.3 volts from the spark core directly from its voltage regulator. The rationale between a small set of pins here and a longer set up here is there's obviously quite a lot of room for expansion here, and I might at a later date choose to add some additional breakouts or components, and generally in the Arduino world they tend to run at 5 volts, so if I want to add a screen or anything like that, it's generally 5 volts. So I've allowed myself some space on the prototyping area and plenty of additional pins. The only other thing left on the board that I haven't talked about really is the these 2 resistors down here, and they're just resistors that tie the 2 of the digital pins to ground. So it's just like any other sort of Arduino switch, where the pin is connected to ground through the resistor, and when the switch is connected, it actually puts 3.3 volts into the pin, and because the route into the spark core is preferable to the route to ground because of the resistors in the way, it'll always go that way. And what that means is it stops the pin from floating between high and low, so when you read your pin you can guarantee you know what the state is. So that really covers the front of the board. Let's give you a full shot there. So let's have a look at the rear. I tried to keep things as neat and tidy as possible here with as little wiring as I could. What you can see is all the interconnects between the various components. So black obviously is used for ground, and I've got the red for 5 volts, and then green is just where there's sort of logic or sort of digital pins, etc. So for example down here you've got the 2 outputs from the relay, and then you've got the sort of 5 volts going into the transistor there and coming back out into the relay, and then that's the line that takes it from the digital pin of the spark core. And you can see there's a lot of pins still available, so there's plenty of scope to add things to this project at a later date. Okay, so the next piece of the LetterBot to talk about is the button press. When I was coming up with the sort of functionality of the LetterBot, its main function really was this doorbell, and I wanted to make sure that people don't have to relearn how a doorbell works in order to deliver a parcel or turn up to the front door. So crucial to that was a standard looking doorbell that doesn't confuse anyone, and everyone understands that that's, you press that button and the expected actions happen. I ordered this illuminated doorbell from eBay, so it was quite cheap. It's just plastic, and to be fair, I might upgrade this at some point because it's quite cheap feeling, but it's quite a rugged button. Unfortunately, this is designed for a traditional 12-volt doorbell system, and the way those work is, you can see I've got 4 wires coming out the back here, but if you ignore the green ones for a minute, I've added those. You just normally have a pair of wires going back to the doorbell, and they provide a constant 12 volts across the switch pins. And if I open up the switch here and just open up this, there we go. So this is actually the switch assembly itself, and what you'll see is instead of what I was hoping for, which was a nice, easy to use sort of LED buried somewhere inside here, what I actually got was this incandescent light bulb, which I imagine gives off a soft orangey type glow. And you can see there, if I can get that into focus, let me use some pliers there. What you can see is that it's got the metal pins actually bent round back on themselves. There we go. So you see the pins are kind of facing the wrong way there, and the way that this goes together normally is, if you can see, these are the switch contacts, so they're the two that are closed when the switch is pressed, and those pins actually sit across those two, so it draws a constant 12 volts, and then this kind of hat that goes over the top, you see there's a piece of copper in there that goes and makes contact where you can see the rub marks there. So it actually works quite differently to how a nice easy switch would work in the world of an Arduino or a Spark core in this instance, where we just want to be able to read a state of is the switch connected or not, rather than trying to grapple with the fact that the switch is always connected because this bulb is in the way. So I kind of decided that it was more hassle than it was worth. It's a 12-volt bulb to begin with, so it would have involved transistors or an additional power supply or both, or some sort of a step-up circuit or whatnot. So just basically a bit of a pain. So what I did is I've moved this around so you can see that it's no longer touching the contacts, and that's because without that bulb in place, these contacts just they get in the way and they don't activate when the button's pressed properly. So that's effectively redundant now. It's just kind of a bit of a placeholder there. So if I slot this back together, what I did was I looked at this board here, or the case really, and I thought to myself, well, it still needs some form of lighting, and there's plenty of space in there to fit some good LEDs. So I started with some ultra bright LEDs, some blue ones, as you can see here. And what I've done is I've actually wired these up so that they're the wrong way around, if that makes sense. So that's sort of positive to negative and then positive to negative. So at any one point, each one of these wires is connected to the positive of one LED and the negative of the other. And what that means is with 2 pins on the Spark core, I can make these LEDs sort of flash one after the other by making one pin ground and then PWM pulse in the other pin. it will sort of make this one light up, and this one will be dull because it's a being a diode. The power won't flow through the component properly because it's the wrong way around. And then we do the same in reverse, and you can see that in the code. Next, I added this tray. So I wanted some way to mount the LEDs really nicely and dissipate as much of the, sort of conduct as much light as possible, and make the most of these ultra bright LEDs. So I just whipped that up on the laser cutter at London Hackspace. It's just, I think, a 2mm clear perspex with a couple of holes in it, just to accommodate the screw holes and obviously where the LED is. That fits really snugly inside this rear casing that came with the light switch, sorry, the doorbell switch. The last thing I did was I lined the insides with kitchen foil, and that was to make sure that the most light is captured and seen through the LEDs, through the button itself, rather than losing it all because it's all been absorbed by the inside of the black case. So that's the doorbell and how it works, and you can see that effectively I've got now 4 wires coming off it, although these are going to be replaced with alarm cable when it's fully installed in the house. So here is the micro switch that I'm going to be using to detect when the post has arrived. So this is going to be mounted inside the letterbox, and the intention is that it will be up against the flap, so when the letterbox is closed it will be holding the button closed like that, and then when the door, the letterbox is opened, it releases, post comes through, and it triggers an action on the spark cord to notify me that the post has arrived. So really dead simple, and there's 2 contacts on here. You've got 3 contacts. You've got your ground there off to the left, and then you've got normally open and normally closed. So you can configure it so that it's activated either when it's pressed or when it's released effectively. And you can see I've just got a little bit of scrap wire here just while I'm testing. That will have, again, I'll use alarm cable soldered properly on there, and this will be mounted probably in a sort of perspex sandwich made on the laser cutter, and then mounted in the door, but sort of the letterbox within the door. And the perspex is really going to be there to try and protect the switch, because the postman, I'm sure, will just shove things through if they're a bit tight, and it needs to be quite rugged, this component. Okay, so one of the crucial features of this device that I'm building, the LetterBot, is that it functions as a normal doorbell as well as an internet connected doorbell. And the reason for this really is you expect certain things to happen. It's quite a time critical function, the doorbell, so you really don't want anything getting in the way of the standard operation. But also there's times when there's visitors in the house, or when family members are looking after the kids. You don't want to have to enroll their mobiles to the phone system, sorry, the doorbell system, to make sure that they get push notifications. So one of the design considerations here was this relay, and the purpose of this relay really was to give me sort of future-proof the abilities to pick whatever doorbell we want in the house. So what this relay does in effect is it actually emulates the button press for any doorbell. So I can take any standard doorbell, and instead of wiring a button press into it, I can just put those cables into these 2 screw terminals, and then when the button on the LetterBot is pressed, it will emulate a button press across those 2, and it will fire any traditional doorbell. Now the doorbell that I have already is a wireless, cheap sort of Amazon wireless doorbell, which the button looks like this. So if I just zoom out a touch there, Now this was just a cheap sort of, I think £10 or £11 from Amazon doorbell, but I really wanted to keep this because it's being wireless, it gives the sort of flexibility of where you place the receiver. It's worked really reliably up till now. Some nice sort of polyphonic sounds out the sounder. I just didn't see any need to change it really. I might in the future add a sort of traditional bell sound, you know, the mechanical type bells, just for sort of nostalgia, but for now I'm sticking with this one. I did originally have a 433 megahertz transmitter as part of this project, because this operates on the same frequency. I don't think it says that anywhere here, but it is definitely 433 megahertz. So I had a really cheap transmitter module for the Arduino, which I used quite successfully last year for controlling Christmas lights on the cheap wireless sockets that you get from the DIY stores. But unfortunately it doesn't seem to want to fire this doorbell, so I've sniffed the RF. Oh well, I've sniffed the signal that this sends over RF, and it sends 20 copies of a binary value, and for the wireless socket simply sending that value out again was enough for the sockets to fire. But this is obviously doing something else. It must have some sort of unique line coding or something like that in how it pairs to the receiver, because there's, as you can see here, there's they obviously used to have dip switches, so you could set the address, but there isn't anymore. So I wonder if they're sort of digitally paired and they send some sort of a key, or there's some you know, RF voodoo going on before the signal gets sent. Either way, I couldn't get the transmitter working properly, so that was sort of where the idea of the relay came from. Now obviously it's not just as simple as taking what would normally be connected to a doorbell, like on a traditional doorbell, and connect it to a relay. I've got to hack this doorbell itself. So you see these the green and red wire protruding from the case, and these are my additions. So if I just open the case up, I'll show you how I hacked into this. Now the downside of this design is that I'll need to continue to maintain this really strange 12-volt battery. They're fairly cheap, but they're just not as easy to get hold of as sort of traditional AAs. But obviously the upside is that at any time, if the LetterBot goes wrong or something happens to the wireless, then I can just put this doorbell back out, and it's still waterproof and it still functions exactly as it should. So that's quite a big benefit. Okay. So see inside the case there is a really simple and fairly cheap circuit board in here, and actually this is that sort of paper board that I was talking about the strip boards typically come as. But either way, what you've got in here, if I just disconnect this battery, is you've got the push button that operates the doorbell, a simple LED which just lets the visitor know that the doorbell's been pressed successfully, and then just you know, a sort of 433 megahertz crystal capacitor, and a couple of other bits and bobs. If I unscrew this circuit board, what I've done is I took two standard jump cables that you would normally use on a breadboard. I stripped the end and soldered them on to the same pins as the existing switch. So if I can get this to focus properly, should be able to see that quite clearly there. Yeah, so you can see here's the pins for the original switch. There's that one there and that one there, and all I've done is I've pre-tinned the wires and then soldered them in parallel with the existing switch. So when that relay makes contact, it might as well be the actual switch making contact, and it triggers all the circuitry on here to fire the signal out. And what's interesting about this board is that it's a really quite reliable transmitter, and it's got quite a good range, but the actual antenna is just this track on the circuit board. So they've obviously done quite a good job of the RF design here and tuned that quite nicely. because traditionally using this 433 megahertz stuff, particularly transmitter modules with receivers on Arduino, it's quite a challenge to get good range and a good clean signal. So despite the fact it looks a bit cheap, it's actually quite a good quality transmitter. So the nice thing about this button really is that there's this void right here, and this is where the dip switches would have gone in previous models. But the nice thing is there that you can see I could coil these two wires up and they sit really nicely in there, and then it all goes back together, and all the rubber gaskets, as you can see the one falling off here, but all the rubber gaskets are still in place, and everything's still waterproof, watertight, and it can go straight back on the door whenever needed. So in the final enclosure, this will be mounted up next to the spark core itself on the other board, and I can just unclip it then and just replace the battery as and when required. And actually in the firmware that runs on the spark core, the first thing that the doorbell function calls is to make that relay go high, so to make the button press effectively. And the reason that happens first is that it doesn't suffer with any of the delays that might happen on the internet or the connection to the Spark Cloud or pushing box, etc. It does that up front, and that's quite a time sensitive function, so at least there is some sound has been made in the house, and then it moves on to the push notifications. Okay, so now we've got the LetterBot all wired up, the doorbell's connected, the micro switch is connected, you've got the relay hooked up to the existing doorbell, and just here I've got my Nexus 5 and LG G Watch, so you can see the notifications, and just so you can see there's no wires there connected between the two. So what I'm going to do, I'm going to plug the LetterBot in, and you'll see this LED starts to flash. The flashing green means it's connecting up to my access point, and effectively when it's breathing that cyan blue, it's all fully connected to the wireless. And you see the LEDs in the push button are now pulsing. I've got plans to upgrade the code somewhat so that this pulsing of the sort of doorbell button only happens after sunset each day, and I'm going to do that using the real-time clock functions that exist in the Spark Core. So what I'm going to show you is a live test. I'll just make sure everything's active there. So if we press the doorbell, what you should hear is the standard wireless doorbell, the phone go off, and also you should see the notification on the watch. Okay, so you can see there in the standard notification tray, we've got there's someone at the door on the phone, and so that was instantly pushed over to the watch. One of the nice features about Android Wear is that it automatically mirrors all of your notifications from all your apps. So I think that's probably blowing the camera out a little bit, but you get the idea. You see there's a door, sort of a bell picture in the background, and it says someone's pressed the door, someone's at the door. We can just now get rid of that, and we're back to the watch face. The other thing, of course, to test is the micro switch for receiving post. So if I just press that, you hear there's the same sound coming out the Nexus 5, and you can see that the notification has appeared now on the watch. I'll get that to focus again. And this time there's a picture of a traditional piece of mail in the background there. The customization of the sounds on the handset actually happens on the local device. So what I do is I set the priority of the push notification through pushing box to be the top priority for the door, so that even if the handset is on silent mode, then I'll still hear that doorbell sound. And it's always a doorbell because that's the priority sound, whereas the letterbox is a lower priority, so you can set the lower priority sound to be different. So I just need to make that back to the default, so it's noticeable between the two. But what you can see here, if I show you my notification screen, you see the mail is here. There we go. So that's the functionality of the LetterBot. Please feel free to comment below, let me know what you think, and if you want to see the code, it's all shared on Hackster. The URL will be down underneath this video. You'll also find my build logs there, and a place where you can look over the history of the project and comment and see what you think. So thanks for watching.